A very good morning, my dear students. Let us start a new chapter from your first PUC syllabus exclusively. The name of the chapter is Units and Measurements. Units and Measurements. In this chapter, we will be focusing more on units. So the things we are going to learn initially in this chapter is about units and dimensions. What is that? About units and dimensions. We'll come to the measurements later. First, we'll be focusing and finishing about units and dimensions. I'm telling you, this is the chapter is only available in your first PUC. There will be no connection with your previous classes of 10th standard and 9th or 8th standard syllabus. Right? Let's start. Units and dimensions. The weightage for this chapter in your NEET exam will be 2 questions. 2 questions is not a small thing. You know, in the competitive world, 1 mark also matters the most. Changes thousands of times. So 2 questions means 8 marks. Out of 45 questions, you get 2 questions from these units and dimensions. Of course, the units and measurements from this chapter I am talking about. Directly or indirectly, there will be minimum 2 questions and maximum 3 questions will be linked with this chapter in your NEET exam question paper. Remember. Let's start the session. You all know about the quantities. Quantities. Around us, there will be so many quantities you will be observing in your daily life. Those are the quantities I can classify into 2 types. Physical quantities and non-physical quantities. Physical quantities and non-physical quantities. Physical quantities are the quantities which can be measured. The quantities which can be measured. For example, mass of an object, length of an object, the time now, force acting on an object, weight of an object, speed of a body, acceleration of a body, all these things you can measure, yes or no. The quantities which can be measured, they come under the physical quantities, right? For example, see, this is what the definition of the physical quantities. For example, mass of a body, length of an object, speed of an object, force acting on a body, force, weight of an object is also a force, okay? Force, this all comes under, etc. This all comes under physical quantities. I have given this much examples about physical quantities and you need to give me the answer for the non-physical quantities examples. If you understand what is a physical quantities, and you will definitely understand what is a non-physical quantity. Physical quantity is what a quantity which can be measured, and the non-physical quantity is the quantity which cannot be measured. What is the non-physical quantities? The quantities which cannot be measured. Examples you have to give me now. Just pause your video, give me the examples of non-physical quantities. Non-physical quantities are the quantities which cannot be measured. We cannot measure them. Right? Non-physical quantities are the quantities which cannot be measured. I'm just writing the example here. Carefully look at this example. All emotions comes under a non-physical quantities. All emotions. Angry, hungry, love, care, everything. The quantities which cannot be measured. In this strict lockdown period, you and your sister or brother, imagine a situation, you and your brother are fighting with each other or with your sister. You're so angry on your sister. How much angry on your sister? My question is, you are how much angry on your sister or a brother? Well, can you measure that? Is it 1 kilogram angry? Is it 2 liters of angry on her? No, right? Imagine a situation, you're so hungry. How much hungry? Is it 2 Newton hungry? Are 50 meters per second hungry you are now? No, right? You cannot measure that. Are 2 kilogram hungry? No, right? So you cannot measure it. So the quantities which cannot be measured are called non-physical quantities. All emotions. But we are talking about the physical science, physics. So these non-physical quantities are not required for us because they cannot be measured. Our name of the chapter is units and measurements. We need to talk about the quantities which can be measured. Those are the physical quantities. And these physical quantities only are classified into scalars and vectors. These are the things we discussed in our basics. Scalars are the quantities which are having only magnitude but not direction. Vectors are the quantities having both the magnitude and direction. Okay. Now, one more important thing here. So these physical quantities again classified into two important type of quantities. Remember, we forget about the non-physical quantities. The physical quantities are again classified into two types. That's the most important part of the session today is fundamental quantities. What are those? Fundamental quantities. Fundamental quantities and derived quantities. Fundamental quantities and derived quantities. What are the fundamental quantities? Fundamental quantities are the quantities which are independent of any other physical quantity in the nature. Fundamental quantities are the quantities which are independent. Look at here. These quantities must be independent of any other quantity in the nature. Those are the quantities called fundamental quantities. And derived quantities are the very important and interesting quantities. And these are the derived quantities always depends on fundamental quantities. Is it clear? Derived quantities are the quantities which are depending on these fundamental quantities. These fundamental quantities are also called base quantities. What are that? Base quantities. I hope you got the concept. These are the quantities which are not at all depending on any other physical quantity in the nature. But derived quantities, all the derived quantities are depending on these fundamental quantities only. And those fundamental quantities are called base quantities. What are those called? Base quantities. Now, units of these fundamental quantities, I am writing here, units of these fundamental quantities are called fundamental units. What are that? Fundamental units. In the same way, units of these derived quantities are called derived units. Understand? Units of fundamental quantities are called fundamental units, and units of derived quantities are called derived units. Clear? Now, look at the interesting part here. What are the fundamental quantities? So that's what I'm going to write here. What are the fundamental quantities? So let's concentrate on the fundamental quantities here. There will be 7 fundamental quantities. How many? 7 fundamental quantities, and they'll have the units also. Units will come back later. 7 fundamental quantities. Number 1, look at here. Mass of a body, right? Length, time, right? Mass, length, time. Electric current, mass, length, time, electric current. Thermodynamic temperature, thermodynamic temperature. Amount of substance. What is that? Amount of substance. Luminous intensity. What is this? Luminous intensity. These all are called, see how many you can count? 1, 2, 3, 4, 5, 6, 7. 7 fundamental quantities are given in physics. Those are mass, length, and time. These are the 3 quantities you get in a physics called kinematics or dynamics. You get in mechanics. Mechanics is a branch of physics, okay? Electric current you get in the branch of physics called electricity. Clear? Electricity. And thermodynamic temperature, amount of substance you get in thermodynamics. Thermodynamics. And luminous intensity concept you get in the topic called light. What I'm going to tell you is, from all the areas of physics, these fundamental quantities have taken. The fundamental quantities are 7. Mass, its fundamental unit is kilogram. About units we'll be discussing later. Okay, I'm just writing the symbol. Fundamental unit of this mass is kilogram because it's a fundamental quantity. Length, it's meter. I'm writing the unit because you're not studying the physics first time in your life, right? Time unit is seconds. Electric current unit is ampere, right? These are the fundamental units. Thermodynamic temperature unit is Kelvin. Amount of substance unit is mole. Okay. Luminous intensity unit is candela. What is that? Candela. For your better understanding, I am writing once again here with a detailed analysis of this one. What is that? Kilogram. Kg is the symbol, but actual unit will be kilogram. Right? So this is meter, right? Meter. Length unit is meter. And this is symbol is S and it is second. Okay. It's A. A is ampere. What is that? A, ampere. And this is Kelvin. Okay. So I'm writing here it is Kelvin. And this is mole. M-O-L. Mole. Alright? And this is candela. CD stands for candela. Okay. Understand? Mole. M-O-L-E. So these are the 7 fundamental quantities and the fundamental units and the symbols. Right? Then what is this derived units here? Derived units. Except these 7 units in physics, fundamental quantities in physics, except these fundamental quantities 7. Any other quantity you take, those are belongs to derived physical quantities and their units are derived units. Let's take an example of speed. For your better understanding, I am writing here speed. Speed is equal to a distance divided by time. Is it correct? Distance divided by time. Distance means what? Can I say the distance is a length here? Tell me, length divided by time. Sure? Speed is a quantity which is depending on what? Length and time. Length and time are fundamental quantities, yes or no? Speed is a quantity depending on length and time. Length and time both are fundamental quantities. Okay, there is a quantity which is depending on fundamental quantities. So that's a quantity called a derived quantity. You can say force, work, energy, power, right? Anything you take it, speed, velocity, acceleration, anything you take it. Those comes under derived physical quantities only because they depend on the fundamental quantities. Understand? So this unit of the speed is what? A meters per second. And this is the unit of speed. Speed is a derived quantity. Then you can say derived quantity units are called derived units. Understand? So this is the basics understanding of quantities, physical and non-physical. Physical quantities are classified into scalars and vectors. That's not our topic for this session. Our topic of the session is the physical quantities are divided into 2 parts, fundamental quantities and derived quantities. And the fundamental quantities are called base quantities, and the definitions here and the units here, and the 7 physical quantities have clearly mentioned 7 fundamental physical quantities. Is it clear? And mass, length, time belongs to mechanics branch of the physics. Electric current belongs to electricity, which is another branch of physics. Thermodynamics, amount of substance, belongs to thermodynamics, one of the branches of physics. And luminous intensity belongs to optics, means a light chapter. Okay, and the units and their symbols also I have mentioned in detail. We will be discussing from the part called fundamental quantities and derived quantities. Now, my dear students, let's continue. So this is the important small topic. In the previous NEET exam also this question was asked on this important small topic. What is the topic is? Any physical quantity can be written in the following way. How? Take any quantity, I am talking about physical quantity only, okay? Any quantity which is equal to, there is a numerical value into the unit. Its numerical value is called the magnitude. No confusions, okay? The numerical value is called magnitude. It's a number. Let's take the quantity represented with the symbol Q, and the numerical value is represented with the symbol N, and the unit is represented with the symbol U. No confusions. Okay. Example also I'll tell you. Let's take an example. Mass of an object is equal to 1 kilogram. The same mass of an object, I can write it as 1000 grams also. Yes or no? Tell me. Mass of an object is 1 kilogram, and the same mass of an object I can write it as 100 gram. right? Mass of the same body I am measuring. I have a wooden block, its mass is 1 kilogram. The same wooden block mass in terms of grams I wrote, it will be 100 grams. Same. I am writing here, both are for the same object. No confusions, right? Let's concentrate on our this one. Any physical quantity can be written in this way. Quantity, see, mass. Mass is a quantity which is equal to numerical value. You can see here, 1 is a numerical value. Unit, kilogram is a unit. Whatever may be the numerical and the units, quantity is equal to some numerical value and unit. So finally, any quantity, see, for example, the first one, I can write quantity is Q, numerical value is N, unit is U. Second one, this also I can write the same way. Quantity is Q, numerical value is N, and unit is U. Very important point here. Quantity is same, Q and Q. Here numerical value is different, here numerical value is different. That's why I am writing it is N1, it is N2. Some different numerical values, right? Magnitudes are different. Units is also different. Here kilogram and here gram. Right? Can I equate these two? Definitely I can equate these two. Because this is Q, left hand side you can see both left hand sides are same. When I equate these, I get N1U1 is equal to N2U2. Okay. What is this? N1U1 is equal to N2U2. I can also write this as N1 by N2 is equal to U2 by U1. Will you agree with this? You must agree. Then cross multiply, you get the same. This cross multiply, you get the same. No confusions. From here, what I can write, a numerical value is inversely proportional to unit. Numerical value is inversely proportional to unit. And the graph between A is inversely proportional to B, you get like this. This is N and this is U and this is the graph. Last class we discussed about the graph. A is inversely proportional to B, the graph will look like this. What you should understand here. You know, from this final expression, the concept will directly goes to the given example. How? Very interesting part I am telling you this. Numerical value is inversely proportional to unit. That means numerical value will be more when the unit will be less. Numerical means what? Magnitude. Magnitude will be more when the unit is less. Magnitude will be less when the unit is more. Concentrate here. 1,000. Numerical is more. Where? 1,000. At that point, unit will be less. Grams. Understand? Numerical is more, unit is less. It's gram. Gram is lesser than the kilogram. Understand? Numerical is less, then the unit will be more. You can see numerical is only 1. 1 is very, very, very less than 1,000, right? 1 is very, very small number, but the unit is more. You can see kilogram. I hope you understand the situation. N is inversely proportional to U. N is the numerical value which is less, then the unit will be more. Understand? So this is the interesting point. And the question I told you, the previous one of the year NEET exam, this question was there. The question was based on this one. Based on this relation. Question can be asked according to the graph. That's a recent graph also I mentioned. Alright? So in this way, even the small topic also we will be discussing so that no question will be missed based on the given topic. Now, the topic is system of units. What is the topic? System of unit. And before that, actually speaking, international system of units. That's the topic. Before on 1960, before 1960, there was three system of units are available with us. Number one, FPS, number two, CGS, and number three is MKS. So this is British system of the units, FPS, and the other system of units are used in different countries and different regions of the globe. And in all this system of units, length, mass and time were the fundamental quantities. But the fundamental quantities we discussed were 7. Before this 7 has come into the place, there were the consideration of only 3 fundamental quantities, which are length, mass, time. In FPS system, length is measured in foot. F stands for foot. Okay. In CGS system, length is measured in centimeters. In what? Centimeters. C stands for centimeter. So simple. In MKS system, M stands for meter. That means length is measured in meters in MKS system. And concentrate on the mass. Mass is measured in pound in FPS. Mass is measured in gram in CGS. Mass is measured in kilogram in where? Kilogram in MKS system. Time, SSS, S stands for second. 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 Is it clear? I hope you understand the situation here. Before 1960, there was a body called General Conference on Weights and Measures. What is that? General Conference on Weights and Measures. I am writing here. A General Conference on Weights and Measures. Before this body exists in 1960, there were only 3 international system of units in which 3 fundamental physical quantities, length, mass and time, they were measured like this. FPS system, in which length, mass and time are measured like foot, pound, second. In CGS it's centimeter, gram, second. In MKS it's meter, kilogram, second. This is same. Time is same in everywhere. But now, after 1960, after the head of this conference, we are not using these systems. What is the system we are using, you know? So that's called International Standard System of Units. That's called SI unit. What is that? SI units. Standard International Units. Understand? Standard International Units we are using. Why? What is the requirement of using this Standard International Unit? That's an important and interesting story behind this. Before 1960, see, not before 1960, and from the basic concept, from the origin of the physics subject, so the scientists were keep on doing the experiments. After finishing a discovery or an experiment, they will be projecting or they will be declaring the discovery or the results of the experiment in some conferences. Before 1960, wherever the conference is held, the scientists across the globe are present at that particular conference and presenting or delivering their result in this way. For example, there are 100 experiments were performed. For example, I am talking about before 1960, 100 experiments were performed in measuring length of this object. The object is same everywhere. In measuring the accurate length of this object. A scientist from one country is representing the length of this is in foot. Some scientist from another country is representing length of the same in centimeters. Length of the same is represented by the another scientist in meters. So it created a lot of confusion in converting these things and in understanding the actual result. So that's the reason in 1960, in this conference called General Conference on Weights and Measures, the scientists or scientific community has decided to have a single system of units, single international system of units, that's called SI system of units. SI system of units works exactly like MKS system of units. MKS, meter, kilogram, second. Along with 4 more fundamental quantities. Understand? How many fundamental quantities here? In general, there are 3. Here it will be 3 plus 4. So total 7 physical quantities, and you know what all those 7 physical quantities are. And their units also here. Very good. Alright. Now, and the most interesting part of this SI unit is there are 7 fundamental quantities and 2 supplementary quantities also are available. What are those? 2 supplementary quantities. How many? 7 fundamental quantities and 2 supplementary quantities together will make SI system of units. Understand? Clear? Now, what are those 7 fundamental quantities? We had already discussed, including their units also. Right? 7 already done. Alright? And we'll be focusing on these 2 supplementary quantities now. And these 2 supplementary quantities, one is plane angle, the another one is solid angle. What is that? Plane angle and solid angle. Okay. And plane angle unit is radian, which is denoted with the symbol RAD. Solid angle SI unit will be steradian, denoted with the symbol SR. Understand? Solid angle, steradian, denoted with the symbol SR. Plane angle, which is one of the supplementary quantities, denoted with a unit called radian, and its symbol is RAD. So in this way, we have finished 7 fundamental quantities and 2 derived quantities, 2 supplementary quantities, and these supplementary quantity units also mentioned here. You carefully see, right? And our next session will be starting from the SI system of units. Understand? Thank you very much.